Hey guys, so last test coming up. I'm going to make 3 little videos. The first video is the chapter 11 questions that you're going to see on the test, then chapter 12, and then chapter 13. All right, so let's look at this one. We've talked about this before. You have a beam here, 8 meters long. It has 30,000 newtons of weight on top of it, and the cross-sectional area is 20 squared centimeters, okay? And the question asks, how much is this beam going to be compressed by this weight, okay? So step number 1 is to convert 20 square centimeters to meters squared. Why do we have to do that? Because when we look at our formula, all right, we're using everything in terms of meters and newtons, okay? So what I usually do is say, okay, if I've got 20 square centimeters, what makes up 20? 5 and 4 makes up 20, 10 and 2 makes up 20, 20 and 1 makes up 20. But I never like using 1 in the math formula because it doesn't act the same way as other numbers. So I'm just going to pick 5 centimeters times 4 centimeters equals 20 square centimeters, okay? So what is this in meters? Well, 5 centimeters is 0.05 meters, all right? And 0.04 meters will give you, when you multiply them together, you get 0.002 meters. Now, in your notes, I did something like this, and it came out to be, I think I had 20 times 10 to the minus 4th. All right, that's the same thing, all right, when you do that, okay? Then, step 2, you're going to solve for the change in length. So you're going to use Young's modulus, which is the 200 times 10 to the 9th, all right, for the steel, okay? I give you that. The force is the weight up here, the 30,000 newtons. This is the original length is the 8 meters, okay? And then the cross-sectional area is what we just calculated is 0.002, and we solve for delta L. So as long as you do your math right, you do your algebra right, you'll get the right answer, okay? So that's one of the first questions, all right. Next question here is we have a barometer, okay? A liquid-filled barometer. An old style one where they would take a tube, they would fill this with mercury, and then air pressure would push down on it, and then it would rise up. So if the mercury rose to 55 centimeters, we want to know what is the pressure at the bottom, okay? So we're going to use pressure equals rho GH, okay? Step 1, convert the height into meters, okay? So 55 centimeters is 0.55 meters. Then we put in the density of mercury, and if we notice the units are kilograms meters cubed. That's why we have to convert the centimeters into meters, because if we don't, you'll be off by a couple decimal points. Then gravity, 9.81, and then the height is the 0.55. Just multiply all 3 together, and that will give you your answer in pascals. Okay? Next one would be buoyancy force, okay? So we have a balloon, and in the balloon, I have a 30 centimeter diameter balloon, okay? A balloon, perfectly circular balloon, and we know that the density of helium is 0.8 kilograms meters cubed. Now, look at the units, meters cubed, all right? So that means the centimeters have to be converted into meters, okay? Now, what is the volume of a balloon? A volume of a balloon is 4/3 pi r cubed. R is what? The radius. Radius is half of the diameter. So step 1, diameter is 30 centimeters, so the radius would be 15 centimeters, which we would then convert into meters, which would be 0.15 meters. Then we get our buoyancy force formula. Density, 0.8. Gravity, 9.8. Volumes, 4/3 pi r cubed, so it's 4/3 times pi times 0.15 meters, and we cube it. You have to cube it. If you don't cube it, you're going to get it wrong. Throw all that together, and that answer will be in newtons. Okay, so that is 3 questions that you need to know from the first chapter.